evaluate the integral of 5x squared exponential 5x dx. So if you look at that, it is product rule, a product of a polynomial function and an exponential function, isn't it? So that is integration by parts. So you let 5x squared to be u, that is a polynomial function. That 5 you make it the coefficient of the polynomial function, isn't it? Then exponential 5x dx to be dv. Integration by parts. Then you start. U is equals to 5x squared. So if you differentiate u, what do you have? If you differentiate u with respect to x, you get 2 times 5, 10x, then you reduce the power by 1, you remain with 10x, isn't it? Are you together? So from there you get, if you take dx the other side, you have now du is 10x dx. We're done with that. You move to dv. The whole of dv is the same as exponential 5x d, but we want v. So it means we introduce the integral on both sides to get v from dv, isn't it? So if you integrate dv, you remain with v, isn't it? When you integrate an exponential function, it remains the way it is, isn't it? It remains exponential 5x, then you divide by the derivative within a function, which is that constant you are seeing there, 5, isn't it? That derivative within a function must be a constant, okay? Are we together? Good. So from there, you now write your formula. The integral of u dv, you are supposed to get uv minus integral of vd, integration by parts, isn't it? If you integrate u dv, you are supposed to get uv minus vdu. So can you now substitute? If you substitute, what do you have? uv is, what is uv? U times v, this times this, isn't it? U times v. 5 cancels with the 5 in the numerator, you remain with x squared exponential. X squared exponential 5x, isn't it? Then it is minus the integral of v du. V is this times du, isn't it? Are you see? So 10 divided by 5, you remain with the 2x, isn't it? You remain with the 2x exponential 5x dx. That is v times du. V is this, du is this. So 10x dx times exponential 5x over 5, you get 2x exponential 5x dx, isn't it? Are we together? Now, it means we are now integrating this part, isn't it? You bracket what you are integrating. So if you look at this, this is still integration by parts. Because it is still a product of two functions, isn't it? So you let the first part, 2x to be u and exponential 5x to be dv. Are you together? Tuko pamoja? So from there, what is your u? What is our new u? 2x. So if you differentiate that, you have du is 2d, meaning differentiating u with respect to x, you get du over dx is equals to 2. If you take dx on the other side, du is equals to 2 dx, isn't it? Are we together? Yes. Then, what is your dv? Exponential 5x dx, the whole of this, isn't it? So for you to get v, you have to introduce the integral on both sides. So if you integrate dv, you remain with v. If you integrate exponential 5x, it remains the way it is, then you divide by the derivative of the inner function. Isn't it? Are we together? So can you now go back and substitute your problem? You know that. What were we integrating initially? We were integrating 5x squared exponential 5x dx, which is equals to this, and we found it to be this, isn't it? We found it to be x squared exponential 5x minus the integral of that, isn't it? That is inside the bracket. So you see the reason why that bracket must be there. Because what is outside is going to affect everything inside, isn't it? Because everything is one thing. Are we together? So what are you getting inside here? See, you are getting integration by parts, which is uv minus vd du, isn't it? This is integration by parts. What is inside the bracket? It is uv minus vdu. Integral of vdu, I mean, isn't it? So what is uv? This times this You get 2 over 5x exponential 5x. Then minus integral of v du, isn't it? V du is this times this. See, 2 over 5 is a constant. You take 2 over 5 outside, then you remain with the exponential 5x dx. You close that bracket. Are we together? You close that bracket. So which part is remaining? There is still integral here, meaning we have to integrate that, isn't it? Before we integrate that, so we have to open this bracket. We have to open this bracket. Let us open it up here. Let us open it up there. So we have integral of 5x squared exponential 5x dx is equals to x squared exponential 5x negative you take inside, isn't it? Minus 2 over 5x exponential 5x, then negative into negative positive, isn't it? That is plus 2 over 5, then integral of exponential 5x dx, isn't it? Are we together? You've now opened that bracket. After opening that bracket, you bracket again what you want to integrate. Anything you want to integrate, you must bracket, isn't it? What do we want to integrate? We want to integrate that part. The other side must remain without an integral, isn't it? So this one is no longer integration by part. It's just exponential function the way it is, isn't it? Are we together? Tuko pamoja? Yes. Good. So what do we have here? X squared exponential 5x minus 2 over 5x exponential 5x, then plus 2 over 5, then inside the bracket. If you integrate exponential function, it remains the way it is, isn't it? So we remain with exponential 5x, then we divide by the derivative of the inner function, which must be that constant you are seeing there, isn't it? Then plus c at the end of the integration process. So you can now open this bracket. 2 over 5 divided by 5 is 2 over 25, isn't it? Are we together? 2 over 25. So we have x squared exponential 5x minus 2 over 5x exponential 5x plus 2 over 25 exponential 5x plus c. And you actually evaluated that given integral. You have evaluated that given integral.